Whenever we have a pair of equations where there are no exponents in either the x or the y terms, we have simultaneous or a system of equations. And we can solve those in a couple of different ways. The first one we're going to look at is graphing here. And so we're going to come across a few different types of systems or simultaneous equations. Some are consistent, some are inconsistent. Inconsistent systems or simultaneous equations are parallel lines, basically. Consistent systems come in two different types. One is independent, and that's where there's exactly one solution, and that's just two lines that intersect each other at some point. And then dependent, which is kind of a funny case because this is actually the same line. It's not really two lines, it's just maybe phrased in two different ways. Let's take a look at graphing method to solve some simultaneous equations. Our first pair here is y equals x plus 5, and then y equals 9 minus x. And you can do this on a graphing calculator, or I'm using GeoGebra. Right, so we're going to find the point of intersection there, and that's 2, 7. And so if we wanted to check that, we would look at, so our x component is 2 and our y component is 7, so we're going to say 7 is equal to 2 plus 5, and that's correct. And then 7 is equal to 9 minus 2, and that's correct. Okay, let's take a look at number 2. Our second pair of equations is y equals 3x minus 18, and then y is equal to 32 minus 2x. And where do they intersect? There's our intersection. So let's draw a point there. We've got 10, 2. So our x component is 10, our y component is 2, or sorry, 12. And so we're going to get 12 is equal to 3 times 10, or 30 minus 18, that's correct. And 12 is equal to 32 minus 20, which is correct. Okay. So again, pretty simple way of solving. X plus y, do it the other way, x plus y equals 12, and then 3x plus 2y equals 14. So we've got an intersection there. These are all consistent, independent equations. There's only one intersection point, and if two lines intersect, there's only going to be one point of intersection regardless. So we've got negative 10 and 22. Negative 10 plus 22 equals 12, that's correct. Negative 30 plus 44 equals 14, that's correct. And you guys can go ahead and do number 4 at home if you like. Same thing's going to work out if we have fractions. Graphing on a graphing calculator or any kind of program on your computer. GeoGebra, the program I'm using here, is available for free. Y equals 1/2 x plus 3, and then y equals 1/2 x minus 5. Okay, so here we don't see any points of intersection, but maybe, just maybe, that point of intersection is way out of view. Okay, and so I made a mistake with A here. Let's try again. Okay, point of intersection. A is just there. B, we got question marks, so they are, in fact, inconsistent. There's no solution. And let's look at the next one, 4x plus 3, 3 plus 4x. Well, we can see those are the same equation already. But let's just go ahead and graph them. Y equals 4x plus 3, y equals 3 plus 4x. And these are the same equations. You see, it even changed them around to mx plus b form. 4x plus 3 is the same as 3 plus 4x because of the commutative property of addition, so these are dependent, consistent equations. Okay, so graphing is only one method. Another method that we can use to solve these two different methods, substitution and addition. And I'm going to show you both substitution and addition for all of these examples. Tennis court dimensions. You can imagine a rectangular tennis court, whether it's singles or doubles, doesn't really matter. It's 4 yards longer than it is wide, and so we have a perimeter and an area. If we got P equals 44 yards, P equals 44, and a rectangle, this is going to be equal to 2W plus 2L. And so we have 4 yards longer than it is wide. So L equals W plus 4. Alright, so let's use substitution first. If L equals W plus 4, then we can substitute directly into the perimeter equation. And so we'll get, we've got 2W plus 2 times W plus 4 equals 44. Combined terms, 2W, we're going to distribute this 2, we've got 2W again, we'll get 4W. And then we'll distribute that 2 over there, 4W plus 8 is equal to 44. We'll subtract this term over here and we'll get 4W is equal to 44 minus 8, or 36. Divide both sides by 4 and we get W is equal to 9. Okay. If W equals 9, then L is equal to W plus 4, which is equal to 13. Alright, so that was substitution. Let's take a look at the addition method over here. Well, this doesn't really look like the simultaneous equation until we rephrase that one there. If we got L equals W plus 4, then we have also L minus W equals 4. And for our second equation, we've got 2L plus 2W is equal to 44. Now, in order to do the addition or subtraction method, we're going to have the same coefficient for at least one of these terms. Right? We've got a negative and a positive, and so that makes it easy to do addition here, because negative 1 plus 1 equals 0. We want to eliminate either the W or the L. Let's try to eliminate the W. So we're going to multiply this one by 2, and we're going to get then 2L minus 2W equals 8. And then we still have that other one there, 2L plus 2W equals 44. We're going to add these two together, just like vertical addition. 2L and 2L is 4L. Negative 2W and 2W, those just cancel out. 8 plus 44 is equal to 52. Divide both sides by 4, we get L is equal to 13, just as we did over here, and then we can plug this back into the original equation. 13 minus W equals 4. And so we can subtract this over here or add this over here. Either way, get the variables on one side, the numbers on the other. And we come up with W is equal to 9. Okay? Same answer either way. Let's take a look at the next example. And so we've got 2x minus 4y. We don't have the same coefficient for either of these, so let's take this one and we're going to multiply it by let's do the substitution method first. Okay? And so if we take this one here, we can add 4y to the other side. We get 2x equals 4y. And then divide by 2, we get x equals 2y. So we'll substitute that into the second equation, and we get 6 times 2y plus the original 8y is equal to 5. Combined like terms, 12y plus 8y is equal to 20y. 20y equals 5. So we'll divide by 20, get y is equal to 5 over 20, or 1/4. Then we'll substitute y equals 1/4 back into either of these original equations. Or over here we get x equals 2y. If x equals 2y, then x equals 2 times 1/4, or x is equal to 1/2. Alright, for the addition method, we're going to do as I had originally started. We'll multiply this one by 3. Let's multiply the top by 3. We get 6x minus 12y equals 0. And we get, for the second equation, 6x plus 8y. Sorry, you sneak a y in there. It's kind of messy, sorry. Equals 5. And we're going to, since these signs are the same, we've got the same coefficient in the x term. Since the signs are the same, then we have to subtract them. We're going to subtract, and I'm going to have to move it over here. 6x minus 6x is 0x. Negative 12 minus 8 is equal to negative 20y. And you can see we're coming up with basically the same thing here. And so we get y is equal to negative 5 over 20, or again 1/4. And then we can take that y equals 1/4 and plug it back into the same equation. We'll come up with that answer right there. Okay. Let's take a look at this next one. Do first the substitution method. If x minus y equals 5, then x equals y plus 5. And so we'll substitute that back into this equation. We go y plus 5 plus y equals 4. And so 2y equals 2y plus 5 equals 4. 2y equals negative 1. By subtracting that over there, we get y is equal to negative 1/2. Okay, if y equals negative 1/2, then x equals y plus 5, or negative 1/2 plus 5, which equals 4 1/2. And so we should come across the same answer if we do the other way, which is addition. We have opposite signs here, so let's just add these together. If we see if I can squeeze it in here, we got x plus x equals 2x. These cancel out. 4 plus 5 equals 9. And so we see again x is equal to 4 1/2. And if x equals 4 1/2, then we'll come across that same answer there. Y equals 1/2. Okay, well, these fractions might look a little bit more serious, a little more difficult. And it is, I suppose, considerably more work. But let's go ahead and work some of these out here. First, the substitution method. Okay, let's take and use this one first since it looked easier to me. Okay, so we're going to get 1/5. Separate here. We get 1/5. 1/5 x. 1/5 x will add this y term over to the other side. 1/5 x is equal to 1/10 y minus 1/10. Okay, that seems easy enough. And then we're going to multiply the whole thing by 5 to get x alone. So x equals 5/10, or 1/2 y, minus 5/10, or minus 1/2. And so x equals minus 1/2 plus 1/2 y. Then we're going to take and substitute that into the original equation. We're going to need some space here, so we'll say 2/3. 2/3 times 1/2 y minus 1/2 plus 5/6 y is equal to 1/4. And then we're going to distribute that 2/3. We get 2 times 1, which is 2, 3 times 2, which is 6. It's our y term, and again, minus 2/6, which is the same as 1/3, but we'll leave it as is right now because we want the same denominator as this y term here, 5/6 y, and then that's still equal to 1/4. Right, so let's combine like terms. 2 plus 5 is 7 over 6y minus 2/6 equals 1/4. Right, so we're going to have to, or 1/4 or 1/3 either way, sorry, 2/6 or 1/3 either way. We're going to take that term, put it to the other side, and we're going to need to find then, let's go up here, so we got 7/6 y, we're going to need to find a common denominator, we'll call it 12, and so 2 times 2 and 6 times 2 is 4 over 12, right, 4 over 12 plus 1 times 3, 1 times 4 is 3 over 12, so 4 plus 3 is equal to 7 over 12. We're going to multiply, cross multiply here. We get y is equal to 7 times 6 over 12 times 7. That cancels out, and that turns into 1/2. Okay. If y equals 1/2, then we can take and put that into the original equation, or the original substitution equation there. X is equal to 1/2 times 1/2 minus 1/2. Half times a half is a quarter. A quarter minus a half is negative quarter. All right, so a little bit messier, a little bit less easy, but not impossible all the same. And just for the sake of consistency, let's go ahead and do the addition method here. So sometimes we can't really come up with an easy way to get these coefficients to be the same. So let's just multiply all of this side by 1/10 and all of this one by 5/6, and we'll use the y terms. So we've got 2/3 times 1/10. I'll write this whole thing out. 2/3 x plus 5/6 y equals 1/4. We're going to multiply this whole thing by 1/10, and then we've got 1/5 x minus 1/10 y equals negative 1/10. Multiply this whole thing by 5/6, and we are going to need some more room. Okay, so what we're trying to do is get the y coefficients the same, so we can just add them together, and what we come up with is something like this here. Arrow over. We get 1 times 2 is 2, 10 times 3 is 30, 2/30 x. 1 times 5 is 5, 10 times 6 is 60, 5/60 y, and we get 1/40 over here. Okay, not really pretty, but not impossible by any means. And 5 and 6, so we get 5 over 30x minus 5 over 60y is equal to negative 5 over 60. Notice we have the same terms here. We're just going to add these together. Okay, vertical addition, 5 and 2 is 7 over 30x, 0y, and we're left with kind of a messy fraction here, but common denominator is pretty easy, 120. So multiply 1 by 3, 40 by 3, and negative 5 by 2, 3 minus 10 over 120, or 7/30 x is equal to negative 7 over 120. multiply and divide here. Get some more room. Put this on the bottom, put that on the top. We get negative 7 times 30 over 120 times 7 equals x. These factor out, we get a negative 1. These cancel out, we get a 4 there. And so that's negative 1/4, which is the same as we had up here. And so finally, we will take negative 1/4, go this way with it. 2/3. Just put it back in this original equation here. 2/3 times negative 1/4 plus 5/6 y equals 1/4. And it's easy sailing from here. 2 times 1 is 2. 3 times 4 is 12, plus 5/6, 1/4. Okay. And let's go ahead and make our common denominator. We'll get a negative 2/12 plus 10/12 y equals 3/12. Add that over to the other side, we'll get 10/12, 10/12 y is equal to 5/12. Multiply 5 times 12, like that, and then divide by 10 over 12 times 10. These cancel out, and we get 1/2. Same as we got up here. Y equals 1/2. Right, so either way, whether you're substituting or adding or graphing, you can find the solutions to simultaneous linear equations.